A ship sails on a bearing of 040 degrees for 12 kilometers, then on a bearing of 130 degrees for 7 kilometers. Find the distance of the ship from where it started, and find the bearing on which it must sail to return home. Now this is not a straightforward question, but a nice clear diagram might help, and I would suggest drawing the diagram reasonably large. So 040 degrees is in this sort of direction over here. So this would be 40 degrees, and this is 12 kilometers. And then it turns and goes on a bearing of 130. So what we need at that point is another north line. 130 degrees is down in this sort of direction, and it goes that way for 7 kilometers. Now our questions both pertain to the third side of the triangle, so how far it is from its start point, and also this is where it's got to sail along to get back to the start point. So both parts of the question relate to the red side of the triangle. Now let's see what we can discern. This is 40 degrees, and these are both north lines. So therefore the 40 degrees and this angle here are co-interior angles, which means that they add to 180. We were given in the question that this angle here is 130 degrees. If we do 360, which is the angle around a point, take away 140, take away 130, we'll find that this angle just here is a right angle. So for part A, we can find this distance, which I'll call d, using Pythagoras' theorem, because we have a right angle triangle. D is the hypotenuse, so d squared is going to be 12 squared plus 7 squared. So we can do that. So 12 squared add 7 squared. It's 193. And then d would be the square root of that. And we can work out the square root of my last answer. And that's 13.89 kilometers. Now for part B, this is the most difficult part of the question. Remember, we also can have a north just here. And because the north lines are parallel, co-interior angles, this is 130, this must be 50, so they add to 180. So if I can now work out this angle, then I can get the bearing, because the bearing is going to be this angle clockwise from north. So I'm going to call this angle x. And if we look at what we know, well, we know d as well, but we calculated that, so it's best to use the sides we were given. So for the x, this is the adjacent, and this one is the opposite. So, car, toa, opposite and adjacent, we're going to use the tan. So tan x is going to be the opposite over the adjacent. So x is the inverse tan. Remember to always do this when you're finding an angle. 12 over 7. So we want the inverse tan of 12 over 7. 59.74. So call it 59.7 degrees for now to 1dp. Well, we know that all the way around is 360. So it's going to be 360, take away the two angles we know. So take away 50, take away 59.7. So that's 360, take away 50, take away 59.7, 250.3, so we'll say 250 degrees to the nearest degree.